Stars have long been a source of curiosity for people worldwide. For centuries, we have gazed at the stars in wonder about what they are and where they come from. Stars are one of the most intriguing aspects of space. Thanks to technological advances, we now know that stars are giant balls of gas held together by gravity. We also know that stars come in different sizes, colors, and ages. Astronomy is the study of stars and other celestial bodies. It is one of the oldest sciences and has helped us understand our place in the universe. Astronomy has also played an essential role in developing new technologies such as telescopes and satellites. Without astronomy, we would not have made incredible discoveries about our universe. For example, we would not know that there are billions of stars in our galaxy and that our galaxy is just one of the billions of galaxies in the universe. Additionally, without astronomy, we would not have been able to develop the technology needed to explore space. Astronomy is a vital science that helps us understand the world and our place in the universe. The oldest stars in the universe are called red dwarfs. One of the oldest red dwarfs is Methuselah, which was discovered in 2005. Methuselah was thought to be around 16 billion years old, making it the most senior star in the universe. It is positioned in the Milky Way galaxy about 24 light-years from Earth. Join us as we explore more about this brilliant and baffling discovery. Although it is ancient, Methuselah is still quite small and faint. It would take about 1 billion Methuselahs to equal the size of our Sun. In comparison to other stars, Methuselah is a true senior citizen. Methuselah was discovered using data from the Hubble Space Telescope. This is a remarkable discovery as it helps us understand more about the universe's early history. Released into orbit in 1990, the Hubble Space Telescope has provided humanity with an unprecedented view of the universe. Named after astronomer Edwin Hubble, who discovered that stars are not static but actually moving away from each other, the telescope has allowed scientists to study everything from distant stars to the formation of our own solar system. With its advanced technology, Hubble has also improved our understanding of the nature of dark energy and dark matter. Moreover, by observing galaxies beyond our own Milky Way, the Hubble has given us a glimpse into the universe's early days. While newer and more powerful telescopes will eventually replace it, the Hubble will always hold an important place in scientific history. The Hubble Space Telescope is a joint project of international cooperation between NASA and the ESA, European Space Agency. The telescope is managed by NASA's Goddard Space Flight Center in Greenbelt, Maryland, whereas the Space Telescope Science Institute in Baltimore, Maryland, carries out Hubble science operations. SDSCL is operated for NASA by the Association of Universities for Research in Astronomy in Washington, D.C. Methuselah is thought to have formed just a few 100 million years after the Big Bang. This means that it gives us a unique insight into the early universe. The star is located in the Milky Way galaxy and is considered part of a population of stars known as halo stars. These aged stars are thought to have formed in the very early days of the Milky Way. HD 140283, or Methuselah, is fascinating not just because of its age, but also because of its location. It lies in a region of space known as the galactic halo, which is considered to be where the first stars formed. The halo is believed to be made up of materials ejected from other parts of the galaxy during the formation of the Milky Way. This makes HD 140283 a key target for astronomers trying to understand how our universe came to be. Methuselah was named after a biblical personality who died at age 969 and was the longest living figure in the Bible. The curious star is situated some 190 light-years away from Earth in the constellation Libra, and it swiftly journeys across the sky at 800,000 miles per hour. Some interesting facts about Methuselah are that it covers the moon's width in the night sky every 1,500 years, and the star can only be viewed with a telescope. From observations of the cosmic microwave background, the universe is estimated to be 13.8 billion years. Therefore, Methuselah's age of 16 billion years was quite startling for scientists. For several years, they've been riddled with the question of how a star can be older than the universe. Methuselah contains just a 250th of the iron content of the Sun. The star is predominantly made of hydrogen and helium. This composition meant the star must have come into being when helium and hydrogen prevailed over the universe and before iron became common. The heavier elements only appeared when massive stars created them in their cores. This suggests that Methuselah is indeed older than the universe, forming before the universe was filled with heavy elements from the supernova. The age of the oldest star has been a paradox. It was believed to be 2 billion years older than the Earth when it was first discovered. Astronomer Howard Bond from the Pennsylvania State University said it was a serious discrepancy. Bearing in mind that Bond and his colleagues ventured out to discover the truth and test the figure's accuracy, their conclusions were just as mind-blowing. A mystery of this enormity could not be brushed aside. Henceforth, Bond and his colleagues attempted to unearth the truth by poring over 11 observations recorded between the years 2003 and 2011. The fine guidance sensors made these observations of the Hubble Space Telescope, which read stars' distances, positions, and energy output. In obtaining parallax spectroscopy and photometry measurements, the scientists could determine a better sense of age. Bond explained that one of the uncertainties with the age of HD 140283 was the precise distance of the star. He explained that it was essential to get this right because they could better determine its luminosity and age. The brighter the luminosity, the younger the star. They were looking for the parallax effect, which meant they were watching the star 6 months apart to see the shift in its position due to the orbital motion of the Earth, which told them the distance. Bond added that there were also anomalies in the theoretical modeling of the stars, such as the actual rates of nuclear reactions in the core and the importance of elements diffusing downwards in the outer layers. Therefore, they worked on the idea that the remaining helium seeps deeper into the core, leaving less hydrogen to burn via nuclear fusion. With fuel used faster, the age is reduced. Bond explained that another important factor was the amount of oxygen in the star. Methuselah had a higher than predicted ratio of oxygen to iron. Since oxygen was not in excess in the universe for a few million years, it points to the lower age of the star yet again. Consequently, Bond and his colleagues estimated the age of Methuselah to be 14.46 billion years. It was a considerable reduction from the 16 billion previously claimed, but it was still greater than the universe's age. In that sense, it didn't solve the mystery, and on the face of it, simply ensured Methuselah remained a curiosity. However, Bond explained that the scientists proposed a residual uncertainty of 800 million years, making the star's age compatible with the universe's age. Bond considered it a breakthrough. Further studies saw the age of HD 140283 falling more. For instance, a 2014 follow-up research updated the star's age to 14.27 billion. Bond said that if one includes all sources of uncertainty, both in the observational measurements and the theoretical modeling, the error is about 700 or 800 million years, so there is no dispute because 13.8 billion years lies within the star's error bar. Furthermore, in May 2021, another group of astronomers reviewed the best estimates for the mass and age of Methuselah. Having modeled how stars change over time, they approximated the star's age to be 12 billion years. It still makes Methuselah extremely old, but it puts the star's age well and truly within the universe's age. On the one hand, Bond said the efforts to date Methuselah is an outstanding scientific achievement that provides robust proof for the Big Bang image of the universe. According to Bond, by referring to the similarities between the age of the universe and that of Methuselah, the problem with the age of the oldest star is far less critical than it was in the 1990s, when the stellar ages were reaching 18 billion years, or in one case, 20 billion years. Bond said that with the uncertainties of the determinations, the ages are now agreeing. However, Matthews believes the issue has not yet been resolved. In July 2019, astronomers at an international conference of top cosmologists at the Kavli Institute for Theoretical Physics in Santa Barbara, California, were perplexed over studies that suggested various ages for the universe. They were reading measurements of relatively nearby galaxies which suggest the universe is younger by hundreds of millions of years compared to the age determined by the cosmic microwave background. Far from 13.8 billion years old, as estimated by the European Planck Space Telescope's detailed cosmic radiation measurements in 2013, the universe may be as young as 11.4 billion years. If that is the case, then Methuselah is once again older than the universe. The plot thickens, but how accurate are these re-estimates proving to be? One of those behind the studies to date on the universe is Nobel laureate Adam Rees of the Space Telescope Science Institute in Baltimore, Maryland. The conclusions are based on the idea of an expanding universe as shown in 1929 by Edwin Hubble. This is fundamental to the Big Bang, the understanding that there was once a state of hot denseness that exploded, expanding space. It presents a starting point that should be measurable, but new findings suggest that the expansion rate is about 10% more than Planck told. The Planck team determined that the expansion rate was 67.4 kilometers per second per megaparsec. Still, the latest measurements of the universe's expansion rate indicate values of 73 or 74. Rees explains that there is a difference between the measurement of how quickly the universe is broadening today and the predictions of how fast it should expand based on the physics of the early universe. It's guiding to a reassessment of accepted theories, while also teaching us that there is still so much to learn about dark matter and dark energy, which are thought to be behind this enigma. A higher value for the Hubble constant points to a shorter age for the universe. A constant of 67.74 kilometers per second per megaparsec would lead to an age of 13.8 billion years, whereas one of 73 or even as high as 77, as some studies have shown, would indicate a universe age no greater than 12.7 billion years. It's a mismatch that suggests, as stated, that HD 140283 could still be older than the universe. It has been superseded by a 2019 study published in the Science Journal that proposed a Hubble constant of 82.4, suggesting that the universe's age is only 11.4 billion years. Astronomers are hoping that the James Webb Space Telescope could shed light on this particular mystery. HD 140283 is just one of many billions-year-old stars in the universe. There are probably billions of stars out there even older than HD 140283. However, their unimaginable distance from Earth makes it much harder to study. Methuselah is an essential key to unlocking the secrets of the universe's history. This discovery is a remarkable achievement and helps us understand more about the universe's history, providing us with an important glimpse into the early universe.